Hi everyone, in this video we are going to solve question number 15 of GATE 2017 mathematical physics paper. The question is from complex analysis. The question says the contour integral dz upon 1 plus z square evaluated along a contour going from minus infinity to plus infinity along the real axis and closed in the lower half plane by half circle is equal to what? So it is an NAT type question. We have to solve the question and then provide the answer in the form of numbers. So let us first draw the diagram. What what they have asked in the question paper. They have told that the contour goes from minus infinity to plus infinity. So if we consider this as minus infinity, so it goes from minus infinity to, let's suppose that this is plus infinity. Okay, and then from there it spans into the lower half plane, that is in this lower half plane from by a half circle. So we just draw a half circle. Okay, so this is a kind of contour, and since the contour is showing, since the question is, it is given that the contour is going from minus infinity to plus infinity, therefore the contour goes in the clockwise direction. Okay, the contour goes in the clockwise direction. Now the integral which we need to evaluate is dz upon 1 plus z square. Now the first thing is to find the poles. So we just equate the denominator is equal to 0, which will give us z square is equal to minus 1, and hence z is equal to iota and minus iota. Now iota is lying outside this semicircle, so this residue or pole would not contribute to this integral, and the only residue or the only pole whose residue will contribute to this integral is iota, minus iota. And we know that Cauchy-Riemann theorem, that this contour integral dz by 1 upon z square, or we can write it dz upon z plus iota minus z into z minus iota, is nothing but, we know that this is nothing but plus minus 2 pi iota residue of the function f of z at the poles. Okay, now we need to calculate only at this pole, single pole, and this plus sign is for the counterclockwise contour direction, and minus sign is for the when the contour is moving the clockwise direction. Since here in the question the contour is going in the clockwise direction, we will retain the minus sign, and we need to calculate the residue of the function fz at minus iota, z is equal to minus iota. So now it is a straightforward question. You just you know that you just as I have also discussed in many earlier classes, that residue of a function f of z at some pole z naught, and the order of the pole is m, is nothing but 1 upon m minus 1 factorial t upon dz m minus 1 z minus z naught to the power 1 fz, and this is limit z tending to z naught. Okay, so we'll apply the similar here. The order is 1, so what will left is limit iota z is minus iota z plus iota, and fz is nothing but 1 upon z plus I, z minus I. So this will cancel out, so what will left is minus 1 upon 2i. This is residue, therefore the integral is nothing but minus 2 pi I times minus 1 by 2i. So 2i to 2i cancel, so you're left with pi, which is 3.14, and we have to provide answer to 2 decimal places, so the answer of this question is 3.14. So this is the way through which we can solve this kind of contour integral. The important thing is to take into consideration the rotation sense of the contour. Here it is clockwise, therefore we retain minus sign. Otherwise, if it contour was going in anti-clockwise direction, then we would have taken plus sign. So, and rest is clear. So yes, thank you for watching this video.